All right, this is another impulse question. We're just having a solve for force given velocities and time. Now, the trick with this one is that we have an angle. So if you look at the vertical component of the velocity, so there's a piece of the velocity here that's going up, and there's a piece that's going to the right. When it reflects back out, there's still that vertical piece that's going up, and there's a horizontal piece that's going now to the left. So which momentum changed? Well, if I look at the vertical, the blue arrows, those are the same size. And so those would have the same velocity, and so there's no change in velocity on the vertical. There is, however, a change in velocity on the horizontal. The red arrows, we can see that those change direction. So the trick in all this is to figure out, well, what's the change? So let's start off with our equation. We know impulse J is equal to force times time. Ultimately, our goal is to find force. That's equal to mass times the change in velocity. In this case, the part of the velocity that's changing is the horizontal component, which if we look at our the angle given, that would be the adjacent side, and so we're going to use cosine. So let me expand out this equation. Force times time is equal to mass multiplied by the final velocity. Final velocity is to the left, so that means it's going to be negative. And that velocity is VF. We're going to do cosine of theta. Then we're going to subtract the original velocity, the horizontal piece of that, V naught cosine theta. So if we are going to solve for the force, that's going to be the mass we have on the right-hand side divided by time. So let's go ahead and plug in some numbers. Our mass is 9 kilograms, parentheses, negative, the final velocity is 6.97 times the cosine. Our angle is 42.5. Minus the initial velocity, which was positive, but it's the same thing. 6.97 cosine, and our original angle was the same, 42.5. All of that is divided by time. And our time was, tiny number, 0.316. So the answer I get for force is negative 292.7. Force is in newtons. Okay, now just to check one thing really quick. Does it want the force or does it want the magnitude of the force? Well, here it says magnitude. Since it says magnitude, we're putting only the numbers, nothing else. No signs. And that's our answer.